Hi, in this video we are going to see how we can derive the expenditure and tax multiplier in a three-sector macroeconomic model. And we have a question or an example with us here, and it reads that given that consumption is equal to A plus B YD, and then as our equation 1, YD is thus equal to Y minus T, that's equation 2, and then Y, which is the national income, is equal to C plus I plus G plus C plus I plus G as equation 3. So C equals consumption as usual, I equals investment, and G equals government expenditure. Okay, so the first thing says we should derive the equilibrium national income, and then we should we should determine the expenditure and the tax multiplier. So let's begin with the first one here, which is A. We have to derive the equilibrium national income. Now, in order to get the equilibrium national income, in macroeconomic theory, for us to have equilibrium in the macroeconomy, we have to equate these two things together, such as aggregate demand to be equal to aggregate supply. Aggregate demand is otherwise known as aggregate expenditure. So if we bring out the aggregate demand out from here, we are going to have aggregate demand or aggregate expenditure, which is equal to C plus I plus G. This is the three sector: household, businesses, and government, or the public sector. So all we have here is I for investment, which represents the activities of businesses. C, consumption, which represents the activities of or the demand for the demand of households. And then G represents government expenditure, which also represents the demand of the government. So this is the aggregate demand or aggregate expenditure. And then we can also see that we already have been given C here, our consumption function. Okay, so all we can do from here is that what then is the aggregate supply? The aggregate supply is just what we call Y. So at equilibrium, we have to say that AD, like we said before, AD is equal to AS. So AS is Y, which is equal to the AD, which is C plus I plus G. So we have C plus I plus G, but then again, what then is C? C has been given here as A plus B Y D. But A plus B Y D, we have been given the function for disposable income. So we input that into our consumption function, and then we have um, brackets Y minus T. Okay, so this is what we now have as our consumption function. Then we add it to plus I plus G. So from here, we have what we call the Y is equal to, so we expand this, we now have A plus, this is BY, and then this is minus BT, and then here we have plus I plus G. So I is a lump sum investment, G is a lump sum government expenditure. So all we have here is that we can bring every variable here that has Y on it, and with it rather we bring it to the other side to meet this other Y here. So we do this by collecting like terms, and we have Y is Y minus, this comes here, it becomes BY. There is no other Y here, so this is equal to A plus BY, sorry, A minus BT plus investments plus government expenditure. So from all we can do here is that we can factorize this, all right, by singling out one Y, and then we have this 1 minus b. So nothing has really changed. This is 1 minus b. So 1 times y is y. And then y times b is minus by. So this is equal to the same thing here, a. This is a minus bt, okay, plus I plus g. So we have this now. If we divide both sides by y, sorry, if we divide both sides by 1 minus b to make y the subject formula, we are going to have that y is thus equal to a minus bt plus I plus g divided by 1 minus b. So this is the equilibrium national income and can be written also further as 1 all over 1 minus b bracket a minus bt plus I plus g. So this is the equilibrium national income, and that is the first part we are asked to determine or to derive the equilibrium national income. Now for the second part here, we are asked to derive also the expenditure multiplier. So if you look at what we have here, this already has given us our expenditure multiplier. Okay, so from here we can derive our expenditure multiplier and also our tax multiplier. But let's see how we can do that from here. So I would erase this now and bring this same up here so we can begin to work with this. So we have b in this case says y is equal to the national income is equal to let's begin with a minus bt plus I plus g all divided by 1 minus b. So we already have this as our equilibrium national income. So now we want to determine the expenditure multiplier. So with the expenditure multiplier, we are looking at the multiplier. The expenditure multiplier is a change, okay, in the income or change in the national income as a result of the change in the on the expenditure component or the aggregate components, aggregate demand components. So which we have this or this, okay, and equally and t here. So if any of this change, then they are going to result to a change in y. So if we are looking at the expenditure multiplier, we are looking at investment and um, government expenditure, because the aggregate demand or aggregate expenditure, like we said before, is equal to a, so is equal to c plus I plus g. So these are the components. So if any of these change, then we are going to have a change in national income. So that is what the multiplier measures, the change in the national income as a result of a change in any of these components. So from here, we can now get the multiplier. So let's say we are looking for the expenditure multiplier, or let's say we are looking for the government expenditure multiplier. So we differentiate this also, the change in y with respect to a change in government expenditure. So we now have this as change in g. So from here, we can call this K and then apply what we call the product, apply what we call the quotient rule in calculus. So the quotient rule in calculus, which says we have u, the v, divided by the x minus v du divided by the x, all divided by v squared. V squared. So we are basically going to apply this rule from calculus. So all we can do is that we differentiate this numerator with respect to government expenditure and multiply that by the denominator. Then minus, we differentiate again the denominator with respect to g, okay, and multiply it by the numerator, Okay, so that's what the v du means. Okay, so all we can do from here is let's differentiate this numerator with respect to g. So the numerator with respect to g will give us our change in y divided by change in g. The numerator, differentiating the numerator with respect to g will leave us, this is g here, and if you differentiate g, you are going to get what we call just a single digit 1. So we have 1 multiplied by replacing everything, add everything here, okay, multiply by the denominator, which is 1 minus b, and then minus, that's this minus. Now we now do the same thing again. We differentiate the denominator, okay, with respect to g, and then multiply it by the numerator. So all we have here is that the denominator is 1 minus b. Differentiating 1 minus b with respect to g, there's no variable here with g, so all we can do from here is that since there's no variable here with g, this will leave us with what? 0. Okay, so the change in g here is 0, so multiplied by what? Everything and the numerator. So we have a minus bt plus I plus g. So we have this, and then we divide it by v squared. What is v? 1 minus b, so the square of it is what we have here. So technically this is 0, okay, or this is 0, yes, multiplied by everything here, so this clears out. So we are going to have the k, or the multiplier, to become 1 minus b, all right, divided by 1 minus b squared. So now this is 1 minus b, and then this is 1 minus b. So this has 2 of it here, so 1 can cancel this. And then what we have here, we have 1 all over 1 minus b. So this is the expenditure multiplier. Okay, so this is the expenditure multiplier, or the general multiplier in the macroeconomic equilibrium. Okay, so the next thing is for us to now determine the tax multiplier. It's pretty much the same step, but it's going to give us something different from this. So if I erase this from here, okay, so I'll erase this so we can get the tax multiplier. Now take note, the kind of tax given to us here is a lump sum tax. Where is it now? Yes, here is a lump sum tax. So it's a tax given by the government whereby everybody pays the same amount irrespective of their income. Okay, so this particular tax is much like very simple to apply in this case, especially if you're given a question like this. The lump sum tax is very easy to calculate if you compare it with the other kind of tax, which has to do with what? Income tax. So with the income tax, it will depend on your income, so that one will be a variable. So in this case, we are working with a lump sum tax, just a general tax kind of, so that's what they call the lump sum tax. So from here, all we can do from here is to derive. Now the second part is what we are doing here, C, is to derive the tax multiplier. So from all we have here, we can now do the same thing here. To get a tax multiplier, we have to look for the change in y with respect to a change in t. Okay, so the previous one we did the change in y with respect to a change in t, but in this case we are, sorry, the previous one we did change in y with respect to a change in government expenditure, but here we are looking at a change in y with respect to a change in government tax. So take note that here we have a negative sign for the variable that has, or that comes with t. That's the tax. That tells you that tax reduces the national income. So there's a negative relationship between the tax and the national income. If tax goes up, the national income will definitely drop down, and the opposite is true. So if we do this now, we are going to see that our KT, which is our tax multiplier, is going to be equal to, we apply that same quotient rule, which says u dv, okay, minus v du divided by v squared. So if we apply this same thing here, we differentiate the numerator, okay? We differentiate the numerator with respect to t and then multiply it by the denominator b. So all we can do here, differentiate everything here with respect to t, we are going to have minus b bracket multiply it by 1 minus b, which is the denominator, and then minus, we do the same thing here again. I'll take this one off. We do the same thing here again. We differentiate 1 minus b, the denominator, with respect to t, and multiply it by the numerator. So we do this here. There's no variable here that comes with t, so this will give us what? 0 brackets, multiply it with here, we have a minus bt plus I plus g. So all you have here is okay, so you divide this now by the denominator raised to power 2. So the denominator is 1 minus b, and then we raise it to the power of 2. So from here we can see that this multiplying this will cancel out and give us 0. So what we have left is that minus b bracket 1 minus b divided by 1 minus b all squared. So now, as usual, this is the numerator has 1 minus b. We also have 1 minus b, but this has 2 of it here, so it's squared. So we can cancel 1 and cancel this one. So what we will have left is that 1 minus b divided by 1 minus b, which will give us our tax multiplier. Okay, so this is how you get your tax multiplier. Okay, so this is how you calculate it, or you solve for the tax multiplier and the expenditure multiplier in a three-sector model. Mind you, this is a case of a lump sum tax. In the next video, I'm going to derive this same expenditure and tax multiplier using the income tax. Thank you. If you find this video, please like my page and subscribe to my YouTube channel. Thank you so much. Bye-bye.